Hello everyone, here's a question involving differential equations and the growth of seaweeds. In such question, I'll show you how we could formulate math statements based on the information given in the question. So scientists are researching on the growth rate of a certain seaweed in an ocean, the length, x meters, of the seaweed at time, t days, during its growth period is proportional to the amount of water it contains. Now the seaweed absorbs water at a rate proportional to the length of the seaweed. Now from this statement, it means that as the length of the seaweed increases, the water absorbed at a given time increases as well. So the rate of water absorption be written as Ax, where A is the scalar factor and x is the length of the seaweed. Now similarly, it loses water at a rate proportional to the square of the length of the seaweed. This could be written as minus bx squared because remember, a negative scalar factor represents the situation where the seaweed is losing water. Now it is also observed that the growth rates are 0.49 meters per day and 0.96 meters per day when the length of the seaweed are 1 meter and 2 meters respectively. So we are to show that x and t are related by the differential equation dx over dt equals to this expression. So we first have to understand what dx over dt actually mean. Now x is the length while t is time in days. So this is the growth rate of the seaweed. And from the question, the growth is proportional to the amount of water it contains, which is simply a combination of the rate of water absorbed and the rate of water lost. So we have put together an expression over here where dx over dt is equals to ax minus bx squared. All we need to do is to take all the information given in the question and substitute it into this expression over here. Now we have a growth rate of 0.49 meters per day when the length of the seaweed is 1 meter. So simply substitute these values into this expression over here and we can then label it as equation number 1. Now similarly, we have a growth rate of 0.96 per day when the length of the seaweed is 2 meters. So we can substitute this as well into the expression and we will then have equation number 2. So the trick here is to actually find a and b by solving the equations simultaneously. A is equals to half while b is equals to 1 over 100. Let's substitute these values back into the original expression. So dx over dt is equals to half x minus 1 over 100x squared. And if we were to simplify and factorize 1 over 100x from this expression, we will then have 1 over 100x, 50 minus x. And this is exactly what we need to show in part 1. Now in part 2, given that the initial length of the seaweed is 0.5 meters, find an expression for x in terms of t. Hence, find the time taken for the seaweed to reach a length of 45 meters. And this is where the solving of a differential equation comes in, where we need to find the general solution of this expression so that we can express x in terms of t. Now from this expression over here, we can simply separate the variables by bringing x, 50 minus x over here to the left hand side of the equation and to keep 1 over 100 on the right hand side of the equation. And all we need to do is to integrate both sides immediately by introducing the integral sign. Now for the term over here, we're going to use the technique of partial fractions to split them into two separate terms so that we can integrate them and giving us a result of a ln. So 1 over 50 integrate 1 over 50 minus x plus 1 over x dx is equals to integrate 1 over 100 dt. Now let's bring all the constants to the right hand side of the equation, and doing so we will have this expression over here where the right hand side is to integrate half with respect to t. Now as we integrate these terms on the left hand side, we will have ln, remember to put a modulus, x over 50 minus x, and this is equals to 0.5 t plus c, where c is an arbitrary constant because this is an indefinite integral. In order to make x the subject, we are going to convert this to an index form by bringing e to the right hand side, and we will then have plus minus e power c multiplied by e power 0.5t. Now I'm separating these two terms of e's because we want to convert plus minus e power c into a, where a is an arbitrary constant representing plus minus e power c. And this makes the working more elegant and simpler to manipulate later on in our working. Now the question requires us to find x in terms of t, so we will also need to find the value of a first before we can do that. So when t is equals to 0, x is equals to 0.5 as written in the question over here. And all we need to do is to substitute that into this expression over here, and a is equals to 1 over 99. Now we haven't fully answered to the question yet. Remember, we want to find an expression of x. So substitute 1 over 99 into this expression here, and we have x over 50 minus x equals to 1 over 99 e power 0.5t. Now simply do some manipulation, such as reciprocating both sides of the equation to get this statement over here. And we can then divide both the numerator by x to give us 50 over x minus 1 equals to 99e power minus 0.5t. Now 50 over x is equals to 99 e power minus 0.5t plus 1, and x is simply 50 divided by 99 e power minus 0.5t plus 1. Now this is the expression for x in terms of t. Now to answer to the last part of the question, find the time taken for the seaweed to reach a length of 45 meters. So since x is the length of the seaweed, when x is equals to 45, 45 is equals to this expression here, and using our graphing calculator, t is equals to 13.6. Therefore, it takes 13.6 days for the seaweed to reach a length of 45 meters. Now I do hope you have learned something from this video of transposing information from the question into mathematical statements, and thank you so much for watching.